For examples 7 and 8, we're going to be looking at Simpson's rule and an error bound for Simpson's rule. So here it is, the definition. Now I want to draw attention to a few things. Many of these are the same. We have delta x is b minus a over n. We are dividing into n subintervals, each of that same length. We have endpoints. However, we do not have a closed form for Simpson's rule. Okay, there's not really a closed form that we're going to be able to use. So we are going to have this written out as just a sum. So we have delta x over 3, that's new. And then if you notice, we have f, just plain old f of x naught. We have 4 f of x1, 2 f of x2, 4 f of x3, and it alternates from 4, 2, 4, 2, 2, 4, up until the very last one. The first and the last are just, we have a coefficient of 1. Another thing I would like to point out is that actually Simpson's rule is derived from using quadratics to estimate things. So it actually gives a better approximation, or at least it should. All right, now we've got this error bound formula as well, and here the difference here is that m is defined as the maximum value of the fourth derivative, not the second, as it was with the trapezoidal and with the midpoint rule. All right, so using that, let's dive into number 7. We're going to use S2 to approximate, or to, the integral from 0 to 1 of x cubed dx. And then we're going to estimate an error bound for S2. All right, so first, we want to find delta x. That is b minus a over n, so that would be 1 minus 0 over 2, or 1/2. That would mean that point A equal to x naught would be 0. x1 is 1/2, and x2 is 1, which is also our b value. Now, from our definition, okay, S2 is going to be equal to, let's see if I can get it up there, is going to be equal to delta x divided by 3. Oh, I need to find the function values, I suppose, for these. Let's back up. F of x0 is 0. F of x1 is 1/8. F of x2 is equal to 1. Now, S2 is going to be equal to delta x, which is 1/2, divided by 3. And then in brackets, and I added brackets to make it clearer, we have f of x0 plus 4 f of x1 plus f of x2. Notice we actually didn't go to the 2. We went, because we're in the middle of 4, and to do that. So the sum of those 3 is 9/8, I believe. Oh, no, once we do the 4, that would be 3 over 2. So this is 1/6, and that sum is 3 over 2, which would mean we have 1/4, and that is S2. Now, doing the error bound is going to be a little different here, because we're going to take the fourth derivative. Well, the fourth derivative of x cubed, just do this. In fact, I don't need the parentheses there. Just the fourth derivative of that is 0. So that means that my error bound, if I go 0 times b minus a to the 5th over this, my error bound, because the m is 0, my maximum value is 0, my error is 0. So I came up with a value of 1/4, and if I find the exact value of integral of x cubed dx, that would be x to the 4th over 4, valued from 0 to 1, is in fact 1/4. The exact area is the value I got from Simpson's rule at only 2 intervals. There's some real power in this. Okay, it is generally a much better estimate. All right, now for number 8, we're going to use S6 to estimate the length of a curve, and it's the same curve we've actually looked at previously. So going back referring back to some values we have before, our length is going to be equal to integral from a to b, so that's 1 to 4, the square root of 1 plus the derivative of y, which is x, and then so x squared. And just let me throw that in here. Integral from a to b, square root of 1 plus dy dx squared dx. That is just the length of a curve rule. Alright, delta x is going to be b minus a, 4 minus 1, so that's 3. 3 divided by 6, because we're doing S6, will be 1/2. Alright, so a equals x naught would be 1. X1 is 3 over 2. Adding a half, that is going to be 2. That is 2.5, or 5 over 2. X4 adding a half to that would be 3. X to the 5th would be 7 halves, because that's 3.5. And x6 equal to our b value is going to be 8 halves, which is 4. Alright, we have ended up from our a to b. Now, our f of each of these, our function of each of these, f of x0 would be the square root of 2. I'm doing some simplification there. And I'm just going to note that's going to have a 1 associated with it. Right, and we have f of x1. Let's see, squaring that, adding 1, that'd be the square root of 13/4. F of x2 will be the square root of 5. That'll be the square root of 29/4. 29/4, f of x4 with the square root of 10. X5 is the square root of 53/4. F of x6 will be the square root of 17. And these have the values associated: 1, 4, 2, 4, 2, 4, 1. Alright, so S6 is going to be equal to, try that again, S6 is delta x, which is, well, let's just write this in formula form first. Delta x over 3 of f of x naught plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4 plus 4 f of x5 plus f of x6. All right, now evaluating using the function values we already determined, f of x0 through f of x6, this is approximately, no equals, approximately 8.1459.